Alright, in this video we're going to talk about how to draw an ellipse. So an ellipse is sort of like a squashed circle, like an oval, and this is the shape of the orbits of planets around the sun. And this was discovered by Kepler, Johann Kepler. And basically an ellipse is something with two focuses. So where I have the string attached here, that's going to be one focus. And then where I have it attached here, that's going to be the second focus of the ellipse. And to draw the ellipse, I just use this string that's attached on both sides and kind of pull it taut and then trace it as I go around here. See, I don't want to get stuck there. So the total length of the string has not changed, but the relative distance between each focus changes as I take the marker all the way around. So this is what Kepler figured out with the planets, is that no matter where the planets are, the total distance from each focus, the sum of those two, stays the same. And that this all works because of gravity, where the sun is at one of the focus spots. So you can imagine a little sun here, and nothing else is at the focus. That one's just empty. So this is true for everything in our solar system. So every planet and every comet is on its own ellipse. So you can see that if I brought these two focus points closer together, the ellipse would be more squashed, so it would be more circular. So if I take them all the way, the two focus points all the way to get to the same place, then that would be the full circle. Kepler said, so he had three laws of planetary motion. The first one just says that planets move in an ellipse like this. The second one says equal areas and equal times. So that one means basically when the planet is close to the sun, it travels faster and it covers more area. So here's the area that it covers in that faster period of time, versus when it's far from the sun, it slows down. So the total area that it covers, and I'm talking about connecting it back to the sun there, even though I can't really draw on that. That total area during that slower period of time is equal to this one. So equal areas and equal times. If the planet took 1 month to travel this distance, and this area is the same, it would take 1 month to travel that distance. The third of Kepler's laws says that the orbital period, which is the time it takes to go around the sun, if you square that, it's proportional to, that's the proportional to sign, the semi-major axis cubed. So the semi-major axis is from the very center of the ellipse to the outside of the ellipse. That's the semi-major axis. So the major axis would be the full distance, but you take the semi-major axis, so that's this length, that's a cubed, and that's proportional to how fast that object goes around the sun squared, which is crazy. Look how simple this is. And it works for every single planet and every single asteroid going around the sun. And that is amazing.